as soon as you see the CircuitPython thing. And here we go.
Happy New Year! That's right. It's 2019. Gotta remember to update your checks if you use checks, which you probably don't. It's a new year. It's a new Snake. It's a new Blinka. We're here doing a little broadcast to kick off the new year.
Yeah, get some CircuitPython stuff.
We do. Well, first off, we should mention, GitHub is amazing. We use GitHub a lot, and, we have 1,000 public GitHub repos. Now, we got everything in there from PCBs to projects. We've got tons of CircuitPython libraries. I think we're up to 120 or 125 CircuitPython libraries. More coming out every week. Don't forget to subscribe to the newsletter, and you can be notified when new ones come out. So, yeah, we've been doing a lot in GitHub. And we've got this big project, CircuitPython is one of our repos on GitHub. So like 1 out of 1,000 of those repos is this magic project called CircuitPython. And we thought for the new year, let's kick it off right with some stars.
Yeah, so this is a neat project. If you're a developer on GitHub, if you have a GitHub account,
you know about stars.
Every time someone stars this repo,
this number
will go up.
Will go up.
And it'll go bing.
And the speaker will go, and then the star will light, and that way you'll know that someone, an angel, got its wings. No, a GitHub repo got an extra star. So my goal for this year is to get to 9,999 stars. no, just because that's the max number you can display.
And
but maybe 1,000. Maybe 1,000 would be a good number.
Yeah.
We have thousands of people sign up to the newsletter and watch our videos. So I think, if people want to star this repo, what repo is it, by the way? It's adafruit.com.
Yeah.
GitHub.com/Adafruit/CircuitPython. Give it a second, because it has to run.
And do you want to start it with it off?
Yeah, actually, let's.
Okay, there's the plug over there.
Oh, yeah.
Why don't you start it with it off?
Okay.
So we could show folks. So it boots up.
Hold on, sorry. Give me a second. This is beta code. But we'll make it happen. So it boots up. It's a Feather M4 running CircuitPython. I've got my ESP32 coprocessor there. This Feather is acting as a coprocessor. It connects to the internet to our local. And what is it? I don't remember. Weird. Maybe it's cached. But the first time it boots up, it goes ding. Interesting.
Yeah.
Maybe other people will star it, and we'll see.
Yeah, we'll see. A couple people are
goes.
starring it now, so we'll see if there's something we got to do. Oh, there you go.
It's happening. It's happening. Thank you, whoever was star number 647.
So it's starting, it should go live. So let's do a tour. What is the different components of this? What's going on here?
Okay, so let's zoom in. So at the top there, we've got the Feather M4. That's our Cortex M4 SAMD51 chip. I'm using it because, I like to have a lot of extra memory, a lot of extra flash. And this chip has that in spades. The Feather has... Oh my goodness, we're up to 650. We got 3. We got 3 stars.
So this is
I should have made it go ding 3 times.
Yeah, this is also us testing because this is the first time. We'll show the code in a moment. It's also on GitHub. But this is our live beta test. So some people are recovering on New Year's. We're deciding to test code live.
You know what? If we do this again, I'm going to make it ding once
ding,
for
ding,
every
ding.
time. Yeah, I didn't. Okay. I knew people would star it, but I didn't think 3 would star it at the same time. Anyways. Feather M4, and I got a little NeoPixel. You can barely see it. This little yellow NeoPixel means it's connecting. Oh, we're up to 654.
Yeah. I thought maybe we would get up to 700, but we'll see.
What? I don't know. If people really like CircuitPython that much, that would be wonderful. Okay, and then in the middle there is a prop maker wing. This is like my favorite Feather wing that I designed this year. Like, I know we do a lot of Feathers, and I love all of them equally, but the prop maker wing is really nice because we looked at a lot of people's props, people making like lightsabers or people making cosplay props, and what's a Feather wing that kind of gives them everything they need to get going. So what's cool is it's got a little speaker connector. So here I've got the speaker and it's connected, and it can drive high current outputs. It's meant to drive high power RGB LEDs, and this star actually takes 100 milliamps, so it's meant to run off a couple AA batteries, but I just wired it directly. And so I'm using that part, although you also have a NeoPixel port. An earlier version that I built had NeoPixels, but I'm basically using the speaker output and then that high current MOSFET drive. And then over here is a 7-segment display. You get 4-character 7-segment. With CircuitPython, it's really easy. You can actually just like print the number. So you see we're now up to 658. And we have these in a couple different, we have like quad segment and stuff, but this is super easy, and this is all on a tripler. And I actually made it so you could stack these, but on purpose, I put it on a tripler so you could see them all. I will mention for the people who are wondering, if you unstar and restar, it doesn't count. So you have to keep it starred. Like, don't unstar and restar, because that's not, it will only look if the number increases past the last highest number. So you'll see, like, it went up and then it went down, so it's not going to reward you for cheating. No cheating hearts here, no cheating stars. Okay, and then over here at that ESP32 feather that I'm using as a coprocessor. See, there you go. We're up to 659, a new high, close to 660. I think we can get there. And I'm using the ESP32 control library that we've been working on. Oh, we're at 660.
Not bad.
Pretty good. Thanks to Jerry Ann and a whole bunch of people, Roy in the chat, who have been helping out testing. We've, even this I've uncovered even more little things. There's a little details when you're doing AT command Wi-Fi. It's always funny when like people are like, "Hey, how are you doing this like Wi-Fi connection?" I'm like, "Well, I'm using AT command," and they're just like, "You mean like a Hayes modem?" And I'm like, "Yeah." So that's where we're at. So it's a little iffy, but it does work. As you can tell, it can connect to the internet. One thing that's nice about the ESP32, some people are probably asking, why not use the ESP8266? Well, I'm glad you asked. The ESP8266 and 8285, which is kind of the all-in-one version of the 8266, do work, but they're a little bit slower, and they're flakier, and they don't have as good SSL. Like, they don't have enough memory to do, I think, like TLS 1.2 or something. And I don't know exactly what's up, but basically, I couldn't get the AT command set for the ESP8266 to connect to GitHub. GitHub is the reason I'm using that as a demo is it's very picky about security, which you would be thankful for. I mean, they take security very seriously. 662. So you can't connect to their API without TLS SSL, which is good, but they require, a very high quality SSL connection. And the ESP32 has enough memory and processing power to manage that encrypted connection, but the ESP8266 sorta doesn't at all. So that's why we updated to the ESP32 on this. But, it's not that much more expensive. I'm thinking of maybe making a little breakout for the ESP32 like we have for the Huzzah, so you don't like have the, extra battery charging and USB, like maybe just a little breakout that's like this section. So it'll be a little bit more compact. But the feather does work quite well. You just upload the code over USB and then you run it. These are basically the power, ground, and UART connection pins. We've got UART RX and TX, power, ground, reset. So I can reset it remotely. That's a good idea. Power, and then flow control. That's one of the things that we added is hardware flow control that you can enable. And that makes a really big difference. It's very hard to keep up with UART is an asynchronous protocol. I mean, AT commands actually, by the way, are like kind of terrible. I kind of wish people didn't keep using them for Wi-Fi and cellular modules, but like they do. So we're stuck with it. But if you're stuck with it, adding hardware flow control, makes a big difference.
Yeah,
makes it much more reliable. It's not perfect, but it's better.
Someone asked, are we using webhooks? So do you want to dive into the code? Because we're not.
We're not. This is quite simple code.
Yeah, so let's go take a look at the code.
Yeah, I'll take a look at the code. And, okay, so over here, look at this. It's picture in picture. So yeah, this is actually based off of an example I have that does any kind of JSON capture. There's so many places that you can go to get, if you fetch a URL and it gives you back JSON, it's an API. Ooh, we leapt past 666 and went straight to 668.
Yeah.
Nice. So as you can see, we're using the Adafruit CircuitPython ESP32 control library. I got a couple other libraries to help me out, like that segmented library for the HT16K33. That's the driver for the 7 segment here. I'm not using NeoPixels actually here, but like an earlier version, I had a NeoPixel star. And then the UJSON library, which is just awesome. It does all that JSON parsing for me. If I get back a web page with JSON data, I just shove it into the UJSON parser, and that's built into the CircuitPython in C. That's not a pure Python module. It's a C module in CircuitPython, so it's very fast. One trick that I came up with early is I was inspired by the Arduino secret file name, where you can keep your stuff in a file called like secret, and you won't have to actually save your Wi-Fi settings. So in this case, it's all kept in a file called settings.py, and actually that's where I keep my GitHub token as well. So I don't have to worry about you seeing my SSID or password.
Good for live demos.
Great for live demos, because
like,
you're always, or you accidentally committing it, and you can never really delete something from GitHub history.
Yeah.
Got a couple config things. Okay, let's keep going. So as you can see, I'm connected to api.github.com/repos/adafruit/CircuitPython, and you can actually go to that URL right now in your web browser. You don't need an API key. You do if you want to connect a lot, like very often. You can connect up to, I think, once a minute, like 60 times an hour. If you don't have an API key, if you have an API key, I believe you can connect 5,000 times an hour. So. You know what? Get a token. It's free. If you have a GitHub account, just generate a token, and then within that, when you get that chunk of data from api.github.com, what you're looking for is an entry called stargazers count. So that's the number of people who have starred your repo. Okay. Next up, we're going to create that UART. You see here we got the UART object, the reset pin RTS that's ready to send. That's the flow control. Next, we create the ESP module. You can have a couple settings here, like, for example, what is the default baud rate and what's the run baud rate. You can change the baud rate to speed it up if you want. ESP hard reset, I create the I2C to interface to run the segmented display. And then I have a couple pins. The power pin, that's on the prop wing. That's what powers this speaker. So basically it's the speaker enable. And the star pin, and that's the pin that is basically connected to the MOSFET that will drive this LED star, which is basically 5 white LEDs in parallel. I have a status NeoPixel. Okay, keep going. So then I can do some init stuff. Basically I have a coin.wave. That's the ding sound that plays. We will keep track of the last value and the current value. And I do that so that, as you've seen, if people unstar, it doesn't, it only checks the highest last value, not the change from the last query, to avoid people from unstarring and starring. Like I want to, you want to keep, if you start it, keep it starred, because then the next person to start will cause a ding instead of you. I have a function that does the chiming and the light stuff for me, just a little helper function. And then, okay, I guess, basically the star value, when it's true, that means the light turns on. Play sound on change means it will play the audio and then stop. And then get value is a little JSON helper. What I do is, when you have the JSON response, I also pass in a list. See, it's like Python is so cool. Like, you can just pass in like lists of items, and then like you don't have to worry about like var args or like, like managing memory or whatever. So I pass in a list that tells me how to drill down into the JSON. So that little loop there that it extracts value from a JSON parses it, and if it parses okay, for X in location means it will just keep drilling down the JSON file until it gets to that value and then returns it. Okay, now we're finally to the main loop. This is the main core code. I can connect. There's some connection code up above, and then, if it, tries to grab the data, let me see, it says retrieving data source. Actually, let me go a little bit to show the loop. Because one of the things that when you do Wi-Fi is you have to have a lot of like nested loops. So I set the status LED. I check if I'm connected. If I'm not connected, I connect using my settings file. If I am connected, I request a URL. I just have a little helper function in my library called request URL. I'll give it the URL. It'll give me the header and the body. Another really cool thing about Python is like, look at that interesting construct, the header, comma, body equals. If you return a tuple from a function, you can assign multiple values. You know, this is something that if you're coming from C is like totally weird and like grotesque. Like, how can you return 2 values? You can return any number of values you want as a function if they're in a tuple object. And then here in this line, the header, comma, body, that line 124, I split it apart. And then if I want to look at the HTTP header, I can look at that. You know, it has some details, whatever, status, timing, whatever. And then body is actually the JSON data. And then, you know, exceptions are another cool thing. Whenever you're doing a lot of Wi-Fi stuff, exception management is something that, you know, helps you avoid getting into a weird spot. So you'll see a lot of try except stuff. And then finally, you just have the logic code that checks, you know, what's the last highest value. If the value is higher than the last value, like it is now, because we got to 669, it chimes, it lights up, and then it sets the last value to that value. So that's like kind of the standard, you know, button debouncing. This is value debouncing, right? You're only looking for the highest value. And then here's another thing that's kind of a good Python practice, especially if you're doing CircuitPython or MicroPython. Yes, we have a garbage collector. The garbage collector, you know, runs in the background whenever you need to. But I noticed that if you want to run some of these things, especially when you're grabbing like huge chunks of data, like the JSON file that you get back from GitHub is like 20-something K. It's pretty big, and you're buffering the whole thing. When you get past what you're done, you know, all those gigantic chunks of data, set them to none, and then garbage collect. It will force all that data to get flushed out, so you don't get fragmentation. So it's kind of normally you don't have to do it, but I noticed that when you're dealing with these big chunks of data, and something like Wi-Fi that's running over and over and over and constantly getting new gigantic chunks of data, don't wait for the garbage collector to run, because by then you might be too fragmented, it might be too late. Run it, if you're doing this time sleep thing, you're waiting around for a second or two, run the GC. You know, it only takes like maybe half a second, and you know, it means that it doesn't run again later, and then you can run forever. You don't have to worry about fragmentation. So a couple little tricks that I've learned here. Okay,
and for the folks that want to ask some questions about this, we're in Discord, adafruit.it/Discord. Go to the live broadcast chat and we'll answer questions. We'll also look around the other chats. But this one's from Cascade. How can we optimize a similar setup for low power use? And would we be able to leverage the power of the ESP for other uses on top of the Wi-Fi stuff eventually?
Yeah, for the ESP32, you know, I mean, the AT command set, which I'm using currently, has Wi-Fi and Bluetooth. So you could add some very basic VLE support, again, whatever is exposed through the AT commands. I think long term, I might want to go with what Arduino did with the Arduino Wi-Fi. They, 671. Nice.
Yeah.
Jumped right ahead of 670. I think there's some desynchronization, but I think, like, you know, the website doesn't update at the same time as the API, which is kind of interesting.
It's all within like
it's within a minute.
It's all within it's all within a few seconds. Plus, there's a delay because we're live broadcasting.
Yeah.
I'd say. By the way, this is a success. We don't really know what's going to happen when we go live often.
No.
And
anything can happen.
Anything can happen. And one of the cool things with GitHub is, you know, stars to show that you like the project, and it doesn't cost anything. You just put a star, and that lets us know that you're interested in CircuitPython.
You don't get email or anything.
Yeah.
Like it's just you start it. I mean, you know, you can then find it later if you want to. So what we were going to talk. Oh, what else you can do with the ESP32?
Yeah.
So the ESP32, we're using this AT command set because that's kind of what is distributed with it, and it's like available. But long term, what the Arduino Wi-Fi boards do, which I think is interesting, is they have an SPI code base, and then they kind of tunnel a socket API over it. And I think SPI is the way to go. You know, that's what we use for our Bluefruit modules, and you know that it's not asynchronous. So you can clock it much faster. It uses more pins, but then you don't need flow control. So it's kind of like in the end you end up with the same number of pins. You know, and then using that on the ESP32 instead would let us have more control too, because then we could add more functional commands. I mean, I don't think I would use it for like a floating point coprocessor. Like it would take too long to send data back and forth to do a lot of computation. So I don't think I would do that. But I think for Bluetooth, you know, it can do BLE, it can do Wi-Fi. You know, it can also do server. It can do an access point server. You don't have to do just client. I'm using it as a client here because, you know, I'm like that. I like doing, you know, connecting to an internet service, getting JSON data, parsing it out, displaying some stars. But you can have it as an access point as well. So you could have a CircuitPython server if you wanted to.
Okay. Mr. Certainly says, nice project, thank you. Stuff with Kirby says, will there be a future feathering with the Wi-Fi chip for ease of use with the M4 Express feather?
I am thinking about that. I really wish there was a smaller ESP32 module. That's kind of what I might look for. This module, I mean, it's really chunky. But, you know, I could absolutely use it for a feathering, but I also want to figure out, like, this SPI versus UART, because it's like a different set of pins. If we're going to use SPI, I think, you know, that would work quite well, but we have to kind of settle on, like, which one to use, because it's, I don't want to make one feathering that's for UART and one for SPI.
Okie dokie. And I think those are all the questions.
All right, cool.
Successful demo.
All right, Christian was 671.
Yeah.
Nice. All right, we're up to 672.
Yep.
Big increase, nice work, and it worked. Just pretty amazing.
Yes, it did work. So we'll maybe we'll have it on Ask an Engineer or Show and Tell, and we'll invite people to try it out.
This is portable. And what's nice is because, you know, the settings.py file is just on the file system. One of the things I like about it is that, you know, if you want to set it up anywhere else, you just plug it in, change, you know, the text file to the SSID that you're at, and save it, and it just will magically work.
And if you're doing live video electronics like we are, you don't have to worry about exposing your secret keys and stuff like that.
Yeah,
you can put it in.
You guys don't know my keys.
Yeah.
See that Blinka? She's so cool because she's like, you don't know my keys.
All right, so that's a repo. You can go check that out. And
maybe we'll do other, you know, we have a bunch of services that we tried out.
Yeah, we did cheer lights.
That was sorry.
We're also on Reddit. We have a CircuitPython Reddit. Twitter followers, Instagram, you know, all those things that, you know, it's not a contest to see who has how many. It's just, here's ways to use JSON and other types of lightweight formats to do IoT stuff. And it has immediate, like, oh, look, I'm doing it. And it's somewhat collaborative. Like, we're on a live video right now, and you know, a lot of you are like, oh, cool, this is like something I could star and just like watch. And you know, you saw it happen live.
Yeah.
That's kind of neat.
Worked out. All right, 672.
Code plus community. Okay.
Nice. What did we start at again? It was like 6:30.
6:30. Yeah, I'll look.
Okay.
I'll look when.
Right.
I'll look when the video's done. I'll be like,
thank you to the 30 people
thanks.
who starred. I hope you like CircuitPython. Keep your star active. Don't unstar, please. But
that's it. Thank you so much.
Thank you, everybody. We'll be back with more. Happy New Year.